Okay, so this video is looking at a flood storm hydrograph. Now I'm going to try and keep this as simple as I possibly can. A storm hydrograph shows the relationship between the time of a storm and the amount of discharge in a river channel. And when I say discharge in a river channel, I mean the amount of water within the river channel. Discharge means the amount of water within it. So, two axes. This axis here at the bottom shows the time. This can be different on different graphs. Here I've done hours. Some graphs might show days, 1 day, 2 days, 3 days, etc. But I've just shown hours. And on the side axes, we've got a bit down here for rainfall, which is applying to this little funny looking bar chart down here. But here, we're looking at discharge. So, 2 points to highlight on this. So this point right here at the top of this bar graph, this shows peak rainfall. Peak rainfall. Now this is the point within the storm that the rainfall was at its greatest. And you can see it was probably just after 1 hour after the storm started. The second most significant point of this graph is the top of the discharge line. So this shows peak river discharge. So this was the point when the river was at its fullest, because obviously all the rain has fallen, it's run off the surface, it's gone into the river channel, and the river channel has risen very quickly, and that's why we see this very sharp rise in the discharge line here. Now, peak rainfall, peak discharge. This right here is the most significant point. So, got peak rainfall, peak discharge. This is showing the lag time. Now, the lag time is the time between these 2 points. Peak rainfall, when rainfall was at its greatest, and peak discharge, when the river was at its fullest. So we roughly work this out. So you go down here, there's 5. So we've got 1 hour, 2, 3, 4. So the lag time for this particular storm graph is 4 hours. Now we could take this further. Let's say, for example, we had another line on this. There you go. Hopefully you can see that. So this particular river line, discharge line, the peak discharge is there. So if we measure that, that goes down to 11. So we can then work out the new lag time from peak rainfall and peak discharge of this new line. So obviously that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this one, the lag time here would be 10 hours. So why is that? Why is there a difference between these two discharge lines? Well, the answer may lie within the area, the drainage basin it's flowing through. For example, if the discharge line is rising really quickly here, this might suggest that this river is flowing through an urban landscape, where this particular river is flowing through a more of a rural landscape. So of course in an urban setting the land is going to be more impermeable, where water cannot infiltrate through it, because obviously there's more concrete. So the water is going to hit the ground and the surface runoff will be faster, which is why that line rises quickly. But if you go to a rural setting, a countryside setting, the land is not impermeable, it's permeable, which means water can infiltrate into the ground. So therefore, the precipitation water will still work its way back to the river, but much slower. So therefore, the line doesn't rise as quickly and it takes longer to reach peak discharge. So, in summary, a storm hydrograph shows peak rainfall and peak discharge and the time between the two, known as the lag time. Now, the shorter the lag time probably means it's flowing through maybe an urban area or even a landscape that's really steep, so surface runoff is going to be faster. But if the lag time's longer, probably means it's flowing through a countryside or rural setting, or even where maybe the landscape is flatter, it's got a gentle gradient. So hopefully that helps. Do check out my other video on the physical and human causes of river flooding. I hope they help.